Hello, YouTube. Hello, YouTube. In this very special programming assignment, we will add a VR body to our virtual reality camera inside of the Unity engine game editor. This will be built for native Unity VR builds, but it will also work for SDKs like Google VR. Thank you and enjoy the program. Okay, so I've started with a brand new Unity project, and so this I'll probably build for Gear VR, so I'm just going to switch it over to Android. And in the player settings, I'm going to tell it to use virtual reality supported, and the Oculus SDK should work fine. And now, this should work for the Oculus platforms. And since I've set it to Android, that's going to be Gear VR. Okay, so the camera is set up. Let's import from the asset store the Locomotion package. Unity Locomotion. Here it is. Mecanum Locomotion Starter Kit. I'm going to import this package. And it comes with some well, I don't need any scripts. I'm going to write my own. I just want the animations. And I don't need the controller. I'm going to make my own. I don't need any skyboxes. There's a test scene with some textures. And I don't even want a nav mesh. So we're just going to get a model and some animations and a scene. So I could open up that test scene. And there's going to be some scripts missing, so I'll just get rid of that. Okay, I want to make this my VR body. I'm going to move the main camera, and I could put it in a good spot. Let me just put it to 0, 0, 0. Now, we're going to have to move the main camera, so we need to make an empty game object, and I like to call it VR main. And I'm going to move that to 0, 0, 0. And make the main camera a child of that. And the reason why is because we have to move the position of the camera, and that's required to have it to have a parent and move the parent's transform, not the camera's transform. Now I have a script that's in my mobile VR movement pack and some of my other packs, and it's called VR mouse look. And it just lets me move my camera with Alt and tilt it with Control. So I'm going to create a folder called Scripts. And I'm going to bring that VR mouse look script in. If you want to find a script like this that gets applied to the main camera, and it lets you move the camera with Alt. This isn't a very good example because it's in the ground, but you can move the camera with Alt and tilt it with Control. And there's a good example of how to do that in the Google VR SDK. So I have simple controls. This is just for the editor because when I build it to the Gear VR, it works. The camera rotates with the headset. So now that I'm able to emulate the head movement in the editor, and I can test things out, I'm ready to get started. And if you want to take a look at this script, I'll just put it on the screen for a moment and you can pause. And like I said, that's also, it's available in my packs, but it's also, an example like that's also available in the Google VR SDK. Okay, so let's make this move with our head. Now, first of all, I'm going to need a basic animation. I'm going to look at the character, and we're going to need to create an animation controller. So I'm going to say create animation controller, and I'm going to call it VR player, and assign that to the animator that's on the player. And then let's look at this animator, which is available through the animator window animator. Okay, so let's create a new blend tree. And I'm going to name this Locomotion. And then if we go into the blend tree, I'm going to add a motion field. And we're going to add some more later. But for now, let's just add the idle animation. And then I'm also going to want a new state for turn left. And I'm going to want a new state for turn right. In turn left, we have a turn on spot left A, and a turn on spot right A. And we're going to need to go to the different ones, but let's see if the character is idle, and it is. Now I'm going to move the camera to a little bit better spot here. Just so I can see what it looks like. And I see some eyeballs in there, but I don't feel like this is a very good idle animation for VR because the body is swaying way too much. And when I'm standing with my VR headset, I'm not swaying my body that much. So I'm going to get a different idle animation. Okay, so back on my animator under the blend tree, I'm just going to assign a new idle animation. And that one should be a little bit better for VR, where the body isn't swaying so much. Okay, now in order to get the body rotating with the camera, we're going to have to write a script for this. So let's go to the character object, because this is the one that needs to rotate with the camera. And we're going to add a new script, and follow VR head rotation. I guess makes sense, because the body needs to follow the VR camera or the VR head rotation. And let's open up that script. Okay, let's define some variables. We're going to need to know where the parent of the VR camera is, because we need to move it. So we'll say VR main object. So public, and this is a transform, public transform VR main object. And what that is this right here, the VR main object, because we need to move the camera. So we need to move that. And then we're going to need a, we'll give ourselves a public float for the camera offset X on the X and the Z axis. And I'll explain that in a second. Camera, well, a public float, camera offset Y. And let's get a public float for the body turn angle. So at what angle do we need to turn the body? Make more sense in a second. So let's get a private animator. That's my the animator that's on this player object. We want a private vector 3 for the VR mains rotation, and also the body, this character's rotation. We're also gonna need access to the main camera's transform. So let's say private transform VR camera, and then we're gonna use 2 extra floats, X and Z. These are going to be used at runtime for calculating the camera position. Okay, so when the script starts, we're going to need to get the animator. So we'll say my anim is get component animator. So this script is here. It's going to find that. And then we need to get the VR camera, which is camera.main.transform. And then if it's not, you need to make sure that the main camera has the main camera tag. Okay, then in update, we need to get the VR heads rotation. And we also need to get the player's rotation. And so now that we have both rotations, we know the rotation of the camera, we know the rotation of the player. We can know when the camera has rotated too far in one direction and the body needs to rotate to match the camera's rotation. And so we'll say if mathf dot delta angle VR rotation dot y and my rotation dot y. So if that angle is greater than the body turn angle that we've defined, and I think I'll set a default to that of 20. So this should give us this should tell us when we need to turn left. And I think what's happening is the script here is probably set to 0 because I never gave it a 20. And we need to set a VR main object like that. Okay. So now we should know if the camera rotates too far to the left. There we go. It's telling us to turn left. Okay, so that's working. So we want to do a left turn. So let's say my animation dot set trigger, and we'll set a trigger called turn left. So back on our animator, we're going to need to, I'm going to go back to the base layer. And we have this left turn. I'm going to make a new perimeter, a new trigger, and it's going to be called turn left. And it will not be ticked by default, and we will make a transition from the blend tree into turn left. And the condition for that will be if the turn left trigger gets triggered. Now we don't want to have an exit time or a fixed duration. Maybe I'll set it to 0.1 here. So it transitions very quickly. And let's see if it works. Good. Okay. There's just no way for it to go back. We'll make a transition back here. And that will be exit time because we want that animation to finish playing. Okay, now it's not the best behavior yet, so let's keep working on the script. So before we go any further on this, there's going to be some issues with the animation once the camera is tied to the head. So let's get the camera following with the head. For that, we're going to use late update because late update is run after the rest of the update function, and that's when we need to move the camera because during update the body may move, and so the camera needs to move during late update. And so we have our two values, X and Z. We're going to set those now. So X is equal to camera offset XZ, which we need to set, multiplied by mathf.sine, and we need to say VR camera dot rotation dot Euler angles dot y multiplied by mathf dot degrees to radians. If you want more information on this, take a look here. And I'll put the link in the description. And this is essentially the math. We'll talk about more about what we're doing here as far as the math goes. The Z we want to calculate as well. We need to calculate that by getting the camera offset XC and multiply that by mathf.cosine of the VR camera dot rotation dot Euler angles dot y multiplied by mathf dot degrees to radians. And then we want to set the VR main object's position. This moves the camera. And so we're going to take the current camera's position and add onto it a new vector 3, which is the X value that we've calculated, the camera offset Y, which is, we define that above, how high up the camera should be, and the Z value that we've calculated. Now let me stop and just go back here for a second. What's happening here is there's your head, your eyeballs, which is the camera. When I'm standing straight up and down, my eyeballs, they're a little bit offset from my center position. So you can see where my mouse is here. This is like the center of my body right here. Right now, if I'm standing perfectly straight up, my eyeballs are almost in the center of my body, but they're kind of like, you know, right here and right here. So they're offset a little bit. So if I were to spin in a circle like this, my eyeballs are not actually rotating at 0, 0, 0. They're rotating at some unknown place, like around here. Now it gets a lot farther away from 0, 0, 0, my eyes do, when I look down. So say I have a VR headset like this, or this, like this or this, and then I look down. You're going to notice that my head, because of my position of my head, my eyeballs are going like this. And now my eyeball's in a position about here. And that is farther away from 0, 0, 0 when I'm looking down than when I'm standing straight up. So when you look down and spin in a circle, you can't rotate at 0, 0, 0. You need to actually rotate. Basically, your eyes rotate like this. So we've set an offset for the X and the Z, and that's for this axis and this axis. We're looking straight down at the top of the head right now, like this. So we set an offset value for this and this, which is, I don't know what a good value is, 1.8 or 0.18 maybe. I don't remember. Let me look at my other project. 0.18. So I've set 0.18 for the offset on the X and the Z axis, because this script is going to determine in real time where that position is on the X and the Z plane. It's somewhere where this black line goes. And depending on where the player has turned, we need to move the camera some unknown X, Y, Z distance. And so this value that we've set for the offset of XZ is the distance from here to here. And at runtime, it's going to, this script that we have just written right here, these two lines, are determining this position where my mouse is as I turn my body. Some unknown runtime value of where the camera should be on the X and the Z planes. Now we also need to set an offset for the Y, so that we can set how high or low the head is. But let's take a look. And the camera needs to be at 0, 0, 0. So you'll see the camera's at the feet now. And that's why I need to come in and set an Y offset. Maybe I'll do 1.8, because I think that's at about the top of the head. So when we hit play, I don't know where the guy's at. He is floating to the sky. Okay, there was a major typo. This should not have been a plus equals. This is supposed to be plus. So the VR main object's position, so this guy's who moves the camera, his position is equal to the body's position plus a new vector 3 of the X value, the camera offset Y, and the Z value. And so let's hit play and see what happens. Everything looks good. And so if I look at the VR main, you'll see that it's at Y is the 1.8. That's the offset that I set. And it's calculating the X and the Z values at runtime based on where the head is rotated at. And if I turn left, the body should turn to match. But right now, a couple bad things are happening. For one, that body is rotating by animation, root motion. And you'll notice that as I stand here, the camera is swaying like this. And that's going to make me sick in VR because I'm not swaying like that. So we need to hold that camera still. If we look at our animator, you'll see that it has root motion. We need to turn that off. And now the head isn't going to be bobbing back and forth. And when I turn, it will play a turn animation with the feet. But because the root motion isn't there, the transform is not being rotated. So we need to rotate the transform. When we turn the body, we are done with late update, and the camera is correctly following the body. However, we need to make this turn happen. So we could program this ourselves with C#, and that's probably a good thing to do. But to make things fast, I'm just going to bring in iTween. And so here's the iTween GitHub project. I could, this is the script that I want. So that has the itween.cs file. And you could also get this from the asset store. So I'm just going to bring that itween.cs into my project. Okay, so the reason why to use iTween here is they have a real nice, easy rotate to function. So here is the rotate to function. And so let's go ahead and use that to rotate the body. When we play the animation, we're going to say itween.rotate_to, and rotate to wants a game object. So that is myself, which is the body, and then we're going to need a new vector 3 for, which is my rotation on the x-axis, the VR camera's rotation on the y-axis, and my rotation on the z-axis. And then this last parameter is time. I'm going to say 1 second. Rotate to 1 second. So this is says itween rotate to, make this game object rotate to whatever my x and z rotation is, but match the y rotation of the VR camera. Okay, so it's following. You know, the feet look kind of funny, so you might want to pick a different animation for your left turn. And let's do something else here. This one's a little hard to explain, but basically, if iTween is already running, because what happens is if you look at this and I go into my game, I start to make a turn, and then I pause, you're going to notice on the object that's rotating, an iTween script has been applied while that iTween rotation is happening. And so if a rotation is happening, we don't want to trigger any more rotations. So the easy way to check that will be just to say, if this game object does not have a component called iTween, because when I paused it, it currently has a component called iTween, which means that a turn is currently in progress. And so as long as it does not have an iTween script, so there's no turn in progress, then go ahead and make a left turn. And that should prevent some of the additional animations from playing, because we're using a trigger and that trigger is getting triggered multiple times. And it's triggering to do a new turn while the turn is in progress. Okay, so we need to do the same thing for a right turn, and we obviously can't do a right turn or a left turn at the same time, so we'll make that an else statement, and we'll say if it's less than the negative body turn angle, then we want to trigger the same thing, except we want to make it a right turn, and we're going to make a trigger called right, and we're rotating to the same place, just match the rotation. And so we need to go back to our parameters here and add a new trigger called turn right, and make a new transition, which is triggered by the turn right trigger and a transition back. Now this one does not have an exit time, not a fixed duration either, and it just I want to make sure it makes that transition very quickly, and it transitions back. It does have an exit time, and it transitions back when the turn animation is finished playing. And so I believe we should be able to turn both left and right with our body. Any direction we spin should pretty much match up. Now, yeah, I can see down my neck. And there's also, this is something I haven't perfected yet, but if you look back, something funny kind of happens because you end up looking this way. Doing that in VR actually turns out to be really hard, because you have to end up looking basically like this, and it's not natural. I never ever end up looking really past this spot naturally in VR unless I'm really trying to stretch that far. So anyways, you might want to account for that, or model a neck down there just in case the player rotates that far. But this is a simple way to get the a VR body turning with the camera. And in part 2 of this tutorial, we're going to be just continuing on where we left off, and we're going to be doing locomotion. We already got a start for that. We got the blend tree for it, but the only animation in here is idle, and so we'll be going into walking, running, basically VR movement. When you move, how do we get these legs moving so that it matches up, so that when I'm moving, I look down and my legs are moving correctly. So stay tuned for that. All right, I hope this very important lesson helped you in your studies. And remember to always stay intelligent. Thanks for watching, guys.